So welcome to the first video of the playlist. We are going to start dynamic programming from the very basics, right? So the first question is Fibonacci numbers. This question is not only easy, but it also gives us an insight as to why do we use dynamic programming, right? So let us first read the problem statement itself. So the problem is saying, right, Fibonacci numbers, commonly denoted as Fn, form a sequence called a Fibonacci sequence such that each number in the sum is the sum of the two preceding ones starting from 0 and 1. That's it, right? So f0 is equal to 0, f1 is equal to 1, and this is some formula they are giving us, and you have to give the nth Fibonacci number. Let us understand this problem more closely by in the drawing board itself. So so let me get the problem statement itself from here. Yeah. So let us get this problem statement on the board itself, right? So this is the problem statement we are having. Let us take a closer look on this. Yeah. So let me directly tell you what is Fibonacci numbers and what is Fibonacci sequence, right? So f0 is always 0 and f of 1 is always 1. 0, 1. What is f of 2? It is f of n minus 1 and f of n minus 2. So the second number, this is the 0th Fibonacci number, 1th Fibonacci number, second, third, fourth and fifth. Let us see. Second one will be the sum of 0th and 1th. So it will be 1. Third Fibonacci number will be the sum of 1th Fibonacci number and 2th Fibonacci number, fn minus 1 and fn minus 2, right? Our previous Fibonacci number and the previous of previous Fibonacci number. So 1 plus 1 is 2. Fourth will be 1 plus 2 is 3. Fifth will be 2 plus 3 is 5. And sixth will be so on, it will be 8. This will be 13 and it will go on forever, right? So this is a Fibonacci sequence they are giving us. They will give us n and we have to tell what is the nth Fibonacci number, right? So in other words, if n is equal to 3, your output should be 2. That 2 is the third Fibonacci number. If n is 6, 8 should be the output. That 8 is the sixth Fibonacci number, right? So I hope you got the problem statement and what the problem is actually trying to say, right? This is the Fibonacci sequence and they will give us an n and you have to tell me that what is the nth Fibonacci. Now let us take a closer look as to how we are going to approach this problem recursively, right? So a direct formula is given in the question that f of n is equal to f of n minus 1 plus f of n minus 2, right? That is the nth Fibonacci number, right? So a recursive relation in this problem can be identified easily if I want the nth Fibonacci number, right? This depends on the sum of n minus 1th Fibonacci number and n minus 2th Fibonacci number, right? So I will write a recursive function, right, which will give me nth Fibonacci number. Let us see what does the recursion tree will look like in very simple and short terms. So if, for example, n is equal to 5, we want the fifth Fibonacci number, right? So if we want fifth Fibonacci number, so I'll simply say f of 5 I want. So this should return the fifth Fibonacci number, right? But first, to return something, we have to calculate what is the fifth Fibonacci number. What this function is going to do you know the faith and expectation of a recursion? Now, faith is something when, I'm keeping faith on others that they will do their task correctly. And expectation is something that I will do my task correctly. So f of 5, it is made by what? It is made by f of 4 and f of 3. So if this person, f of 4, gives me the fourth Fibonacci number and this person, f of 3, gives me the third Fibonacci number, can I say that I'll add them both up and I'll return my answer, fifth Fibonacci number? In other words, if this person does his or her task correctly and this function does its task correctly, I'll be adding whatever their results in and I'll be doing my task correctly, right? So this is the gist of recursive approach, right? Now f of 4, to return f of 4, it is dependent on what? It is dependent on f of 3 and f of 2. F of 3 further is dependent on f of 2 and f of 1. f of 2 is further dependent on f of 1 and f of 0, correct? Now for f of 1 and f of 0, we already know that f of 0, they have already told us that it will return 0, and f of 1 is of course 1. So f of 2 will be what? 1 plus 0, it will be 1, right? F of 1 we already know, so it will return 1. F of 3 will become what? It will become 1 plus 1, which is 2. It will return 2 to f of 4. That f of 3 is like Fibonacci, third number in Fibonacci series is 2, right? Now you tell me, is this person doing his task correctly? Let us check. We want the third Fibonacci number and this person is returning 2. Let us check. Yes, indeed, the third Fibonacci number is in fact 2, right? So this means that my faith is working. Others are doing this task correctly. Now f of 4. It has got f of 3. Now it wants f of 2 as well, right? But can you look at something? ध्यान से देखो यार. Haven't we already calculated the answer for f of 2 earlier? Haven't we already calculated the answer for f of 2 earlier? Right. Now, this is where dynamic programming comes in. Let us first complete the recursion thing and then we will move to dynamic programming. So, f of 2, it is dependent on again f of 1 and f of 0. Now, f of 1 will be having 1 and here will be having 0. This will further return 1 plus 0, 1. 4 will return 2 plus 1, which is 3. Is the fourth Fibonacci number equal to 3? Let us check. Yes, the fourth Fibonacci number is in fact equal to 3. This means that faith and expectations are working fine. Now, let's look at this f of 5. So, it was demanding the fourth Fibonacci number and it was demanding the third Fibonacci number. Okay. But you can see one thing now, that if we are demanding third Fibonacci number will be dependent on second Fibonacci number and first Fibonacci number, right? This further is dependent on first Fibonacci number and n minus 2th Fibonacci number. So let us calculate the results. This is the base case we can say because we already know the answer for this. F of 1 is 1, f of 0 is 0 and 2 will return 1 plus 0, which is 1. F of 1 is 1, we already know. F of 3 will become 1 plus 1, which is 2. So f of 5, the fifth Fibonacci number is 3 plus 2, which is 5 according to us. Are we doing our task correctly? Let us check. So f of 5, yeah, is the fifth Fibonacci number 5 only? Yes, it is. So we are doing our task correctly and this is how recursion would look like in this problem. Okay. I hope you got the flow of recursion. Let me write the pseudo code for recursion here itself. So first I'll be writing a function. Recur. Right, it will be demanding what Fibonacci number we want to return. Okay. It will be of course integer return type. Instead of function, I simply write integer return type. So what are the base cases? Yeah, if n is equal to 0, I already know the answer, and if n is equal to 1, I already know the answer. So if n is equal to 0, I should return what? 0, because 0 is the 0th Fibonacci number. Return 1 because 1 is the 1th Fibonacci number. Now 0 and 1, the task is done. What we have to do next, we have to write the recursion suggestion. For example, if n is not 0 or 1, we have to calculate the answer for that. And to calculate the answer for that, what should I do? I'll calculate integer Fibonacci n minus 1. Fibonacci n minus 1. Right. And here I will demand for what? I will call the recurrence function recur. I'll pass n minus 1 because I want the n minus 1 of Fibonacci number. Similarly, in the next line, integer f of n minus 2 is what? I want the n minus 2th Fibonacci number, so recur n minus 2. Now, assuming that they will do their task correctly, I'll be having both these numbers. And if I want to calculate the nth Fibonacci number, the result would be simply return f of n minus 1 plus f of n minus 2. Okay. And this is the pseudo code which we are going to do on the lead code itself, right? Now here we are on the code editor itself and let us write a function which will recursively tell us what is the nth Fibonacci number. So public integer recur. I'll pass an integer n here. Let me zoom in a little bit so that it is more clearly visible to you all. Okay. So if n is equal to 0, these are the base cases. I will return 0. If n is equal to 1, return 1. Now I have this habit of not writing brackets if there is a single line in if statement, right? Because if you are having a single statement, you are not supposed to write brackets, right? So we generally do something like this when we are writing if statements, right? So I have this habit of not writing brackets, and it keeps my code concise. And many of my students also say that it is better, because it every line is in a single line only, right? So base cases are covered. Now if I am not n is equal to 0 and is equal to 1, I want to calculate f of n minus 1. F of n minus 1 is equal to, I'll call for recursion. I'll pass n minus 1 here. Integer f of n minus 2 is the next thing I want if I want to calculate the nth Fibonacci number, n minus 2. Assuming that these two things will do their task correctly, having the faith on them, I will do my task correctly, which is return f of n minus 1, f of n minus 1 plus f of n minus 2. Correct. This is the recursive code. From this function, I'll simply call this recursion code recur, and I'll pass n here. Let us run this code for once and let's see if it works. It is getting accepted on smaller test cases, but if I give it a big test case, let me just submit this problem itself and let's see if it gets submitted. Right. So apparently on lead code, this problem is getting submitted because n they are giving is only up to 30, right? But can you imagine what time complexity this particular approach must be having? It would be, 2 raised to the power n, because at every step we are calling two recursion functions, right? And it will be huge, right? Because n's value is 30, it's able to pass. But if n value is 100, we are not going to, let me if I'll try to give 100 here, lead code will actually not allow me, because they want the input according to their constraint itself. Yeah, expected n to have value 0 to 30 only. But yeah, you imagine, right? If n is 100, what would be 2 is power 100? It would be a very big number, right? So now we have to optimize this code, right? And now here comes dynamic programming, right? Till now it was recursion only, and here dynamic programming steps into the picture to optimize the time complexity to solve this problem. Let us get back to recursion tree itself and let's see if we can optimize this or not. Okay. So can you see one thing which I made you observe in the previous section itself, that here f of 3 is getting called multiple times, my friend. You can see f of 2. Look how many times we are actually trying to calculate f of 2, right? And for f of 0, f of 1, surely we can see we are trying to calculate them multiple times, right? Can you observe one thing? We are doing repetitive work. We are doing repetitive work, right? How are we doing repetitive work? We have already solved the answer for f of 3. Yet here we are again making some calls to calculate what is f of 3 again. Isn't this bad, right? And on this note only, dynamic programming optimizes, and I will draw another recursion tree with memoization, right? With memoization. So let us draw another recursion tree with memoization. What exactly is memoization, right? I'll actually show you the example itself, and then you'll be more comfortable in understanding that. So here I'm going to again draw the recursion tree, but with a twist. You can see I've taken an array here of length 6, right? Actually, I have to take it of length 6, so I'll remove this here itself. So I've taken an array of length 6. So 0, 1, 2, 3, 4, 5, right? So we want to calculate f of 5. ध्यान से देखना है. F of 5, let's continue the recursion. F of 5 is dependent on f of 4 and f of 3. F of 4 is further dependent on f of 3 and f of 2. F of 3 is further dependent on f of 2 and f of 1. F of 2 is further dependent on f of 0 and you can say f of 1 and f of 0. Now I already know the answer for f of 1, right? What is the answer for f of 1? It is 1, right? What is the answer for f of 0? It is 0. Till now it is fine, right? Till now it is good and it is fine. Look at what we are going to do here. F of 2. This was the thing which was repeating, right? And it was making multiple calls. F of 0 and f of 1 were not making multiple calls after them. But this f of 2 is the person who is responsible for making multiple calls. f of 2 can now calculate its answer. The answer for f of 2 is 1. But before returning the answer on this second index, I will store this 1 as well, that my answer was 1. I have memorized the answer for f of 2. Is this clear to everybody? I have actually memorized the answer for f of 2. In future, if someone asks me what is f of 2, I will give this answer directly instead of calling further. So now let's talk about f of 3. F of 3 has done for f of 2. Now f of 1, like f of 1 doesn't make any more calls. This is the base case itself. So directly we can return 1 from here because we already know the answer. F of 3 can calculate its own answer now. And before returning, it will actually, on the third index, it will actually store and remember. The answer for it is 2. It will store and remember this answer and then it will return. Now f of 4 has got the answer for f of 3. Now f of 4 is again trying to call f of 2. My friends, if f of 4 is trying to call f of 2 now, then can you see from here that if f of 4 is trying to call f of 2, we already have the answer for f of 2 here. Is there a 0 in this particular place? No, there is not. This means that I've already calculated the answer for f of 2. I will not make further calls. I will actually return this 1 itself from here. Can you see how much area I have, how much calls I have saved in order to, answer this f of 2. F of 4 can now calculate its own answer, and 2 plus 1 is simply 3. Before returning, it will of course save its answer here. So 3 is the answer, and then it will return this to f of 5. Now we are standing on f of 5 and we are making a call for f of 3. Do I need to make more calls for f of 3? No, because can you see on f of 3 there is no 0. There is some other value than 0, because default it was 0, right? Now there is some other value other than 0. This means that I've already calculated the result for f of 3. I will simply return this result and I'll say that this is my answer. 2 will be returned from here. Of course 3 will be returned from here. Can you see this whole tree would have been drawn here if I would have not remembered the answer. So dynamic programming is just like this. We are trying to identify the overlapping sub problems, right? The sub problems which are coming again and again, right? This is of course a sub problem, right? A smaller section of a problem is sub problem, right? So f of 3 answer has been calculated. F of 5 we are going to return 3 plus 2 5, but before returning, of course, for this as well, I will store the answer here. Now you can see I've got the answer, and if we compare both trees, you can see how linear this tree looks, right? How linear this tree looks instead of this tree, right? So let us quickly code this solution out, right? It will be pretty similar to recursion itself. I will show you some trick as to how to convert recursion into memoization, and then we are going to do tabulation as well. So let's get right into it. So this was our recursive code, right? Let us convert it into memoization. First of all, to convert a recursive code to memoization, I will create a similar function with this, right? Integer. I'll call this function as memo, right? Integer n. And along with this integer n, I will keep an integer dp as well. This array is the array in which I'm remembering the answer. Is this clear to everybody? This is the array in which, this is the dp array I'm remembering the answer in, right? So if you look at this closely, what we have here, I not only have n, I also have this dp of array. Now rest of the function will be pretty similar. This base case I'll copy as it is, right? But from here onwards, I'll check if dp of n, if dp of n is what? If it is not equal to 0, this means I've already calculated. Now, because after base cases, it's time to calculate the answer. If that answer has already been calculated, I will return that dp of n itself. Let me write here. If answer is already calculated, this means that that particular index is not having 0, right? So I'll return that dp of n itself. Here I have optimized. And if I have not calculated that, so I'll of course call these things, right? Of course, this time the function name is memo. So I'll call it memo, right? And passing n-1 along with this dp array, and here also I'll pass this dp array, right? So dp array has been passed and good. I've calculated the answer. At the time of returning, before returning, what did I tell you? if I have calculated the answer right now, before returning, I'll remember this answer as well. How will I remember this? dp of n is equal to fn minus 1 plus fn minus 2. And now I will return the answer. I will return the answer fn minus 1 plus fn minus 2. This is the memoization we have done here. And this is what we have optimized a lot on, right? In the earlier solution, you might say, right, that it was taking very bad runtime, right? Beats only 25%. Let us call this function. Of course, we have to create DP array this time. So integer array DP is equal to new integer. The size was n plus 1, right? This array size was n plus 1 because 5, when n was 5, we were creating it of length 6. So I'll create it of n plus 1. So n plus 1 I'll keep here. And now I will do what? I will return what? Whatever memo function will call. So memo I'll function, I'll call n and I'll pass this DP array itself. And let us see if this function works now. ध्यान से देखना. Okay, so of course we have to update the n's value instead of 100. Let's first run this problem and let's submit this. Okay, accepted. And let's see if the runtime has improved or not. Now it is saying beats 100% of the users with Java, but we can further explore more on this. Instead of recursive calling, we can also optimize it in an iterative way. Now we are going to see the tabulation approach of this thing. So let us see what is tabulation, right? In recursion code, we went from n all the way to 0 in recursion tree. You remember that was top down, right? Now this tabulation is first of all an iterative way, right? And it is a bottom up way. We are going from 0, we are building the answer from 0 all the way to n. N is equal to 5 this time. Yes, and I've taken again n plus 1 size array so that I can have my final answer on this fifth index. Because n is equal to 5, I want the answer for fifth Fibonacci number. What I can do, I already know the answer for f of 0, which is 0, and f of 1, which is 1. Right? We can easily solve it like this as well, that f of 2, right, is equal to, this is of course a DP array. And can I say that DP of I will be equal to DP of I minus 1 plus DP of I minus 2. Can I say this? Yes or no? Correct. So if I am on second, I want the second Fibonacci number, it will be first plus 0. So I'll simply write 1 here. Third Fibonacci number will be 1 plus 1, which is 2. Fourth Fibonacci number will be 2 plus 1, which is 3. Fifth Fibonacci number, which is 2 plus 3, 5. Now in this problem, it is pretty clear that what we are going to do. I can simply write the pseudocode as well, right? You just have to enclose this inside a for loop, right? And it will be easier, right? So let me write the pseudocode for this directly. So for int I is equal to, it will be going from to I less than, you can say equal to n and I plus plus, and this will simply call the, it will just keep on doing stuff. And of course, before using this for loop, I first have to set dp of 0 to 0 and dp of 1 to 1. This is fine, but this problem is easy, right? How can you remember this technique? How can you create memoization to tabulation? Because many of the students face problems in that. I have a trick for that, right? I have a trick for that, right? I hope you understood this method, right? Or let me just code this method out quickly. So I'll just write public int tabulation, and here also I'll take an integer n and integer array DP will be passed to me, right? We should of course use that itself. So what will I do here? DP of 0, I'll say it is 0. DP of 1, I'll set it to 1. And from I is equal to 2, I less than equal to n I plus plus. From this I onwards, I'll say DP of I is equal to DP of I minus 1 plus DP of I minus 2. And I'll return DP of n because that will be containing my answer. Let me quickly call tabulation. And let's try to run this code. Let's see if it works. And after this, I'm going to tell you a trick to convert from memoization to tabulation itself. This is working and it will get submitted as well. Let us look at the trick to convert memoization to tabulation. Look at this. And before discussing further, and before going to the further videos, let me tell you that my handwriting is actually used by law enforcement agencies in order to, encrypt and decrypt stuff. So if my handwriting seems bad, don't worry, right? It is something, like it is for official purposes, right? It is not bad because I write in bad handwriting. It is bad because of some other reasons. Okay, this like many of the students already know, right? So what is good boy or girl DP strategy? Memoization, recursion. First, you have to do this step 0. Step 1 is start the loop from the base cases. Let me remove this tabulation code for once, right? Or let me create another function, public int tab trick. I'll call it tabulation trick. I'm telling you a trick to convert memoization to tabulation easily, and I'll apply this trick in every question we are going to do. Integer n, integer dp will be passed, right? So first, what I'm trying to say here, start the loop from the base case. What was the base case of memoization? Look at this. What was the base case of memoization? It was n is equal to 0. So I'll start the loop from 0. I is equal to 0. I less than equal to n I plus plus. Loop is set. Correct. Convert return. Right. And then after doing that, copy everything in the memoization code in here. Copy everything from memoization inside this loop. Right. So starting the loop from base case to n and then copy all the code here. The next step for the trick is convert return statements to continue statements, right? And if return is having a value, save that in DP and then continue. For example, देखो, if n is equal to 0, we are returning 0 na. Instead of return statements, I'll do what? DP of 0 is equal to 0 and then I'll continue. Instead of return statements, you have to write continue. Return 1 hai, so I'll do DP of what? DP of I is equal to what? 1 and continue, right? Of course, like instead of n, we are having I now. So I have to take n, I instead of n everywhere, right? So just change this n everywhere. So instead of n, of course, we are having a I. So I'll change it to I. Okay. So if I is equal to 0, make it 0 and then continue. Instead of return statements, you have to just replace them with continue. ध्यान से देखो यार. Here we are returning dp of I. Actually, this statement will get deleted. Right, memoization statement will get deleted. This was a statement which was optimizing, right? Just delete this statement because we are building from bottom up. So what steps I'll recollect now? So first do memoization recursion, and then after writing the memoization code, start the loop from base case. Wherever return is written, save the result and continue. Here also we are doing return. Save the result in dp of I and then continue. Right. After this line, of course, loop will be continued. So I'm not writing continue here. Right. So have I done this? Yes. Have I successfully replaced return with continue? Yes, I have. What is the next step? At the place of recursive calls, access DP array. So here I am making recursive calls, right? Instead of making recursive calls, I will access DP of I minus 1 here. क्या करेंगे यार? I will access I minus 1. ध्यान से देखना. DP of I minus 1. Here also, instead of recursive call, I will call DP of I minus 2. Right. And of course, here we are remembering result. Instead of remembering results, it's fine. We'll remove that. And can you see? We have actually achieved the same kind of code we have written above. Only in this time we are starting from 0 instead of 2. And rest of the code is exactly the same. If I return dp of n here, we will get the exact same result. Because this is the trick to convert memoization to tabulation. If you are having some doubts in this trick, don't worry. We are going to solve more problems using this trick itself. This trick will get in your nerves and it will be so helpful in the upcoming problems that it will seem magical that how this trick is working. What are the steps? First, write memoization, then start the loop from base case. Instead of continue, write return statements like save and return statements. And wherever you are making recursive calls, access DP arrays, right? So this was recursion, memoization and tabulation. This problem can be optimized further in terms of space, right? Let's look at optimization, how we are going to optimize. In this particular problem, I can only use two variables and I can use them to solve the whole problem. For example, I want to calculate n is equal to 5. I want the fifth Fibonacci number, right? So I'll set f of n minus 2 f of n minus 2, I will set it to 0 initially. F of n minus 1, I'll set it to 1 initially, setting that this is the 0th Fibonacci number. This is showcasing 0th Fibonacci number right now, and this is showcasing 1th Fibonacci. Right. Let us try to calculate the second Fibonacci number, which will be represented by the variable called current. Now current will be what? This variable plus this variable, it will become 1. Correct. Do I want the second Fibonacci number? No, I want the fifth Fibonacci number, right? So I'll do what? I'll move forward, right? So these two, f of n minus 1 and n minus 2, should represent 1 and 2 Fibonacci number. I want to get the third Fibonacci number. Similarly, the values also, this f of n minus 1 will be sent to f of n minus 2. This f of n minus 2 will be having the value of f of n minus 1, and then f of n minus 1 will be having the value of current. Now this is representing one of Fibonacci number, this is representing two Fibonacci number. Third Fibonacci number will be 1 plus 1, which is 2. Right, this is 2. Now of course, I don't want the third Fibonacci number, I want fifth Fibonacci number. So this gets lost, this value goes here, this value goes here, and we have to calculate the fourth Fibonacci number. Let me update these variables as well. This is second, this is third, and we want to calculate fourth Fibonacci number. Here, what we are trying to get, 1 plus 2 is 3. 3 is the fourth Fibonacci number, and I don't want fourth Fibonacci number. I'll do one more iteration. So this value goes here, right? This value goes here, right? Previous becomes like previous, current becomes previous, and now we'll try to calculate previous. So current. So what will be current Fibonacci number? Of course, like 3 and 4 will go back, and this will become 5. Fifth Fibonacci number. What is the fifth Fibonacci number? It is 3 plus 2, which is 5. Have I got the fifth Fibonacci number? Yes, I've got the fifth Fibonacci number. I'll simply return the current itself. It is clear. And this will be the space optimized solution just by using two variables, because I want to access the previous two variables only. So I can use variables instead of actually creating a whole array out of this. So let us write the code for this. ध्यान से देखना. Space optimization, public int space optimization, integer n I'll pass. I'll take two variables. For example, if n is equal to 0, I'll return 0. If n is equal to 1, I'll return 1. And now I'll start my space optimization. I'll take two variables, f of n minus 1 is equal to, or yeah, f of n minus 1 is equal to 0. Sorry, n minus 2 is equal to 0. Integer f of n minus 1 is equal to 1. What I'm going to do here is just using two variables, simple Fibonacci code. For I'll start from I is equal to 2, I less than equal to n, I plus plus. Integer current will become what? F of n minus 1 plus f of n minus 2, right? F of n minus 2 will become what? Tell me. Now, of course, after calling current, if ith is equal to n, I'll simply return current itself. And if not, I'll move forward. How do we move forward? F of n minus 2 becomes f of n minus 1, and f of n minus 1 becomes current, and we'll go on, right? We'll actually return from here itself, so I'll just write return 0 here. It's just a dummy return statement. It's not important. It's just a dummy return statement, and this code would run in linear time with constant space, right? This is the space optimization here itself, right? So let us write return, and I'll space opti. I'll just pass n here, and this will now simply do the task. Not only because you can see how much space we are taking here. It is by time wise, this was the memoization acceptance, I think, or tabulation maybe. Space is bad. Let's check out both space and time in this time. So space is also coming bad right now, but I think it should, yeah, I think it is working, because we are going through the loop itself, right? Or maybe because we are calling two functions, I don't know. This can be wrong sometimes, but yeah. So here, of course, according to the code, you can see that we are not taking a lot of space, only two variables. Of course, constant space is being taken here, and this is the overall space optimization we have done on this problem. So these are the four solutions to solve this simple problem of Fibonacci numbers. We have solved using dynamic programming. This solution was having 2 raised power n time complexity. this solution was having O of n space complexity, but O of n time complexity. Similarly, O of n space complexity, O of n time complexity. This is this tabulation only, so O of n, and this is O of n space complexity, but O of 1 time complexity, right? So this is it for the first video of this playlist series. I hope you got some idea as to what is dynamic programming. The only thing we are trying to do is we are trying to not make repetitive calls, right? That is what we are trying to achieve, right? So I hope you are enjoying the videos, and I hope you'll be following this playlist through. Thanks a lot for tuning in today, and until the next video talks, bye.